Hi, welcome back to the Unqualified Engineering YouTube channel. In today's video, you will see CNC machine part 3. You can see the finished product right there behind me, but that's besides the point. In this video, you will see me build the machine and just explain what parts need to be fixed, what needed to be changed, and at the end you will have an overview of the machine. That's going to include price, how long it took to build, and important stuff like that, and if it's really worth it to build your own CNC machine with no experience. But yeah, you will see that later on in the video, so I hope you enjoy watching. So I now have all the parts I need to finish the CNC machine. I went ahead and I took apart the Z-axis because I'm making a whole new one of these to put in here to hold up for the spindle. And I bet you guys are wondering what spindle I decided to get. You guys are probably assuming that I bought one of those cheap 70-watt spindles that come on like the other lower end machines. But no, I decided to get a 110 volt DC 800 watt spindle. It's pretty big for this machine, but hopefully I can get it to work. I've designed something. I've designed a mount because this mount's way too big for it, but hopefully it works out. It's almost as big as the cutting area, the Y cutting area. And it also came with a power supply and a potentiometer to control the speed. And it also came with a few bits. So let's hope it works out, but this is going to be fun. Okay, so I realized I have to make a new Z-axis switch to hold the spindle because I tried it with the first version with the wheels and the aluminum extrusion, and the motor couldn't lift the spindle because of the friction. It was like putting a 1.5 pound spindle onto a wet noodle. Not a bit exaggerated, but still. The new one I'm going to be using, or the new one I'm going to be making, is going to use 2 linear rods on the side with the lead screw in the middle, and then bearings and stuff going down. The motor is going to go up with the spindle, so it's going to be an adaptive Z-axis area, so it won't, instead of it just being a space at the bottom where it's like a fixed position that the spindle goes up and down, that's going to go up with it, so I'll be able to put the travel of the Z-axis, I'll be able to put that amount of stock underneath of it. So it's going to be a lot better than the last one. But yeah, I'll show you that in a few seconds. This is a closer look at the Z-axis I've built. So when you turn it to the back here, you can see the same lead screw that was on the last one is right there. But this time I added 2 of these rods, so it has no backlash, and then it rides on this linear rail, so it's very minimal. And also with this one, I really like, is that the whole motor and the carriage moves, so I have super high Z-axis clearance now, which is great. I think I cut this part off, but yeah, it's overall it's a lot better than my last one because it can actually lift the motor, which I think is a pretty good testing part for that. But yeah, otherwise, yeah, this is it. It actually works this time. As well as upgrading the Z-axis, I decided to fix these stupid wheel garbage that is on here that doesn't work. So I got linear slides for each axis here. They're definitely not expensive, super accurate runs, but they're definitely going to be better than those cheap linear rods I had. So it's going to be a lot more rigid and okay, so now I got the rails attached for the Y-axis. So now I'm gonna attach these blocks and the second gantry. or the x-axis, not the second gan. So this isn't even screwed in right now, but this is what it's gonna end up looking like. It's, as you can see, it looks a lot better because it's on rails this time, so it's nice and smooth, unlike the other one. And then that's where the x-axis is gonna slide. So the Z, and I have more 3D printed parts. I just didn't want to put them on here, but yeah, this is what it's gonna look like, and you can tell it's gonna be a order of magnitude better than what it was. Well, just from moving this around, I can tell that it's going to be so much better. Like, oh, this fell off the other side cart because I can't finish this side because I have the wrong size screws. But I'm just going to I need to also make another attachment like this to hold the end of the lead screw. But this, I can actually push it and it moves. That's crazy, man. And this is a bit stiff. I think it's because it's a lower quality rail, but otherwise, I'm really happy with that. And once I get the lead screws installed, this is going to be so smooth. This one is huge. Look at that. It now supports the spindle perfectly, and everything still moves extremely smooth. Oop, that just fell off. But look how beautiful that is. And just like, it's like a little bit of just flex in that, but I think that's acceptable. There's no actual backlash or play. It's beautiful. It's amazing. We got our y-axis working. This is great. Slides so much more smooth. I can't even like wiggle that a little bit. But yeah, now I just have to do the x-axis, which is going to be fun, so see you when I get back. Okay, so now that everything's working with the motion around it after the wet spaghetti noodles of the last gantry, I can finally get into wiring up the spindle for the first spin test and engraving and cutting. So I'll see you once I find a spot for all the electronics and when I get it working. Oh wow, look, a little change in scenery. Because I did not want to do any tests on this machine in my room because it would be very messy, so I'm in my empty garage. But we are about to do some tests on this piece of wood right down here. There's nothing running in this code right now. I'm just gonna make a straight line from here to here-ish, maybe, I don't know. I'm just gonna see what the thing says, but I'm gonna connect my controller. I'm going to start up the spindle. Now I'm going down and so that circle turned out amazing in that last clip you guys just watched. I think it was really good for engraving. But after that, I decided I would need better work holding because those little clamps, they weren't holding it anymore. So what I'm gonna do is I'm going to drill a bunch of holes into this piece of MDF, like one of these pieces of MDF back here. I'm going to drill a bunch of holes into it, and then I'm going to screw in wood set like inserts, so you screw them in, so then I can have a bunch of drop down clamps. But my CNC machine is going to mill all the holes in it, and you guys are going to watch that in a few seconds. So I made the fixture plate to hold parts down on the CNC machine. And as you can see here, it's a bit bumpy, but it should be fine eventually when I level it with the CNC machine. But I have all of these M5 wood inserts, so I can screw down M5 screws into here to make custom clamps with my 3D printer to hold down parts. And that's pretty much about it. And it just drops right down in here. And boom. And I have some screws to hold that down, but it's pretty simple. And I can start doing stuff. So this is the setup right here for my first real part. Don't mind the markings, but it's a lot stronger. It's a lot stronger than you think it would be. But yeah, it's gonna take a really long time, so you guys are gonna see it in a time lapse. Time. So I bet you guys are mostly wondering, how much did this cost? So the CNC machine costed me about $700. It's definitely a lot more money than other machines that you can just buy on like Amazon or whatever, and it's also definitely probably not as functional as them. But the other thing that you have to understand about the CNC machine is I didn't build it because I needed a CNC machine. I built it because I wanted a CNC machine. But then I was thinking about it, and I didn't actually need a CNC machine, and I thought it would be fun to try building one. So I did. I built it, and it turned out pretty good. Okay, it's definitely not like what I said, good as other machines on the market. But now the other question, was it really worth it to build? Depends on who you are. So for me, like, I'm a pretty technically advanced person. Like, I can build stuff. Like, I'm not new to that. But this machine is a challenge for me. So I think if anyone just wants like a CNC machine for its like functionality and actually like use it, don't build one. But if you're like the idea of having a CNC, like you have a 3D printer, then go for it. What's to lose? A lot of money, I guess. But yeah, it's pretty good. It had a lot of waste. It's a lot of iterations. You would definitely have to have sufficient CAD skill to do it. But it was a really good learning experience overall. Like, I think I benefited immensely from this project, and it was the biggest project in my life. And yeah, but overall, I would say it was worth it for what I gained from it. I wouldn't say if I bought that machine for $700 off of like pre-built off from like a website, I would not be happy with the result. I would probably be mad and send it back. But from all the things I've learned from it, everything I gained from building it, I think it was 100% worth it. I don't regret much. I realized I did take a lot of corners, like I cut a lot of corners when I built the machine the first time around with like the wheels, like 3D printed wheels and stuff. Like it was not my best work. But I came around to that, making it more rigid and stuff, and it's still not the best, but I built it and I'm really happy with it. In the next clip, I will show you how much waste this machine brought on me. I think I threw away some parts of the machine, but yeah, I'll get to that. So this might not look like a lot, but it's about 2 kilograms of filament wasted. So that's 2 rolls. And as you can see when I hover over this, it's all the iterations of parts that I had to do to get it to work. And then it's like all of that waste for, I think, and then on the CNC machine itself, there is about, I think, 200 to 300 grams of filament on there. So waste to use ratio on there is not my best work. But like I said, it's all about the learning process. Like all of this stuff right here, it's all wasted and it's gonna get thrown away. But yeah, that's how much waste. That's how much waste I did. Yeah, that's about it. I hope you enjoyed this video, and if you feel like it, maybe leave a like or subscribe even. But I will see you next time. Adios.